Well, good morning, everybody. Welcome to this One Spatial webinar, an introduction to FME Server. We'll be looking at the FME Server product today. My name's David Eagle from One Spatial, and I'll be guiding you through this session for the next hour or so. Things we're going to look at. First of all, we're going to take a look at the product FME Server, very high level, focus on the FME Server architecture, the structure of the product and how it sits on your hardware. And we'll also do a bit of a guided tour of the FME Server interface. For those of you who haven't seen the actual program itself, we'll go through some of the different components in the interface, so that if you want to then go ahead and have a go at an evaluation of the product, then you'll be able to find your way around it a little bit easier. We're also going to take a look at some of the different types of services that are offered by FME Server and what some of those can do for you through some live examples. Those examples are either ones that I've got set up on my FME Server implementation on my machine here, or alternatively there'll be examples that you can access directly via the FMEpedia website resource. There are a number of live examples that you can use and play with to your heart's content over on that website. But first, very briefly, a little bit about ourselves. One Spatial, we've been around for a good while now. We've got, we're headquartered in Cambridge. We've got offices in mainland Europe, in places like Liège in Belgium and Paris as well, and over in Cork in Ireland. And we also have a Sydney office down in Australia. We work with a number of different industry sectors. I have to say, though, that our main core business is around the national mapping agencies of different countries. A few of the organisations are listed there. With a number of other software products, though, we focus on a wider range of organisations, some utilities, large amount of central government bodies, and also local government as well. So a real mixed list of customers that we work with in very different industry sectors, from military through to transportation sectors. We work with several different technology partners. We're focusing on the safe software connection. Our friends in Vancouver in Canada, and we'll focus a little bit on that. We've been around for over 40 years now, and we're very much the spatial big data professionals. We have a number of individuals within the organisation that have a lot of capability around both our technology and technology that sits with partners. Here's a few of some of the main customers that we're working with at the moment, and we have a much longer list, obviously, but you're not here to find out about that today. What I want to focus on really is the level of specialism that we have in the business for a number of different technology stacks. We obviously are software developers in our own right. We have our own technology that sits in a number of organisations, and that's the One Spatial technology stack, the One SMS suite. We do a lot of work with Oracle. We have a number of very skilled DBAs within the organisation, and we also work with a number of third-party components, and we have consultants that specialise in technology from people like Snowflake and the open source stack and Pitney Bowes and Esri. We'll be focusing, though, on our staff who understand FME very well. Though we have a number of certified professionals and trainers globally who can help you out with your FME requirements. Safe Software, really briefly, it's their 20th anniversary year this year, so they're celebrating that. I'm very proud of their long history in the ETL world, extract, transform, and load, and the FME product set is sold into a lot of different countries around the world. A huge amount of users of FME, because Safe Software, the vendors have carved out a great niche for the product. it has a lot of capability interoperating between different environments, whether that's a corporate Oracle database environment, moving data across to perhaps an open source environment over in PostGIS, or vice versa, whether it's moving data between Esri and perhaps Bentley, so a CAD to GIS problem, or whether it's moving data up into the cloud in either a Salesforce CRM or perhaps some of the Amazon or Microsoft cloud-based services. SAFE really has that connection to all of those different environments, and it's why FME is where it is as a product these days. These three tag words describe the capability very well. Connect, i.e. connecting to an input data source, whether it's one or more environments. Consuming data into a process that then restructures it and makes it fit for purpose for a target environment. And the ability to automate that kind of process and make it as hands-free as possible is very much the key message, what we want to try and achieve, to build this harmony between different types of applications. The different products that SAFE produce are FME Desktop, FME Server and FME Cloud, and we're focusing on the one in the middle today, this FME Server toolset. There'll be a little bit of coverage of FME Desktop, but that goes without saying really. You'll see why shortly. As a capability then, we've been a value-added reseller and we're a platinum supplier for FME and have had that relationship with SAFE for a good while now. We've got plenty of dedicated staff to help you out either on technical support or consultancy, and we do quite a lot these days of facilitated product evaluation. So if you're looking today to evaluate FME Server, or even just wanted to know a little bit more to understand how that sits with FME Desktop and you want to evaluate Desktop, then we can help you do that, and we'll give you as much help as you need to get up and running with the product before you consider a purchase. So please do drop us a note at fme@onespatial.com if you need any immediate assistance on that front. So focusing then on the product stack, FME Desktop and FME Server are a server and client pair. You use FME Desktop to create your FME workflow, your ETL routine, extract, transform and load is ETL, and you build the workflow, the task that you want to be carried out, and then you can run it in FME Desktop. So you could translate a folder full of AutoCAD DWGs and publish that across to perhaps a single MapInfo tab file or a handful of MapInfo tab files in a folder. But you may want to make those tab files available to somebody outside of your business. They may want to be able to access that data, and you want them to always have the latest data, so you take that process and you publish it up to FME Server and scale up and make that into an FME data download service. So now the person at the other end has the ability to access a web browser and download the MapInfo tab files from that environment. So it's a nice quick approach to be able to publish that content in a way that users can self-serve that data. So there's lots of buzzwords around FME Server that really focus on the kinds of things you'd want to hear when you are moving into an enterprise environment. So things like failover, distributed, scalable. These terms don't mean enough without being described, but effectively scalable means that you can just make sure that as your needs change over time, you can adapt FME Server to be able to cope with a higher throughput, and I'll show you that in a short while. Distributed means that you can put different components of FME Server on different machines. With FME Desktop, you install it on one machine and you use it on one machine. With FME Server, you can put different parts of the product on different hardware, physical hardware or virtual hardware, and make sure that should one component fail for any reason, it will fail over to another identical component on another machine, and your environment hopefully will stay up 24/7, and that's the kind of thing that you're looking to achieve for some of the use of FME Server, having a service that people can call on and rely on. And there's a number of our customers that have just that environment where FME Server supports that capability, and they are providing a service to fee-paying members of the public who are accessing data over a service. So, if we have a look at the process through the medium of a little animation here, FME Server can be described by showing you users of FME Desktop. Here we have 3 FME Desktop users running FME workspaces on their machines. Each machine is operating a little bit slower or faster than one of the others, but as with a lot of software, when you carry out a heavy-duty ETL process, you consume quite a few of the desktop machine's resources to carry out that process. So ideally what you'd look to do is to move your environment to FME Server. This has a number of benefits. One is that you can publish your process into the server environment and free up your desktop resource so that you can do your day-to-day job, have your email client open, have your GIS open, and focus on those applications and carry out transformations on a server. Secondly, server hardware is often more capable, so you can see that you might have solid-state drives, for example, in a server environment. You might have a greater number of CPUs or a larger amount of RAM over there. So now you're offloading your ETL process onto an environment that is more capable with coping with heavy-duty data processes. One benefit, though, of having that process available on FME Server, though, is that your colleagues, whether they are within the organization or perhaps contractors, third-party individuals outside your organization, can now log into a web page and run a job. So they can carry out a task, whether it's just a basic transformation, or whether they physically want to download something, or they want to stream some data into one of their web applications. All sorts of capabilities now are suddenly open to them through the fact that you have published your process. Obviously you'd apply the right levels of security and make sure they can only access certain components, but that's a detail that you can manage. The other benefit you've got is that any individual within your organization can download the process at any point, either then run it locally or adapt it and republish it, so that different versions of that process can be made available to different individuals. So it's a life cycle of this ETL routine that allows a much larger, broader base of users access to potentially a complicated process, but in a very simple way through a web page. So now lots of people can use FME, and they don't have to even know that they're using a product. It could be disguised as a simple web page on your intranet or on your main website, and people are clicking drop downs and pushing go and producing some output without realizing what's doing the work behind the scenes. FME Server's licensing then focuses on a concept of an engine. So with FME Desktop, you buy FME Desktop and you get an engine. If you start FME Workbench, you see in your task manager that you have FME Workbench.exe sitting there. As soon as you push the green run button, the FME exe will start, it'll run, process your data, and when it's finished it stops and that FME.exe closes down. With FME Server, depending on how many engines you've got, will depend on how many FME.exes you've got permanently running on your machine. So they don't start and stop, they are always running, always listening for a job. So it means that if you've got small processes that don't take very long to run, you don't have that extra load of the time to wait for your engine to start and stop. It can listen and run the job very quickly. Licensing is on a per engine basis. There's no awkward licensing rules that mean that depending on the hardware, depends on how much it costs. Basically, you buy FME Server, you get it with one engine. If you want more than one engine, you buy additional engines. Each additional engine, is the same price. The only thing that we suggest is that you don't have more engines than you have CPUs. So if you've got a machine that's got 6 CPUs in it, then you wouldn't want to have more than 6 engines running on that machine. Of course, as I mentioned before, you can put engines in different places. So if you have more machines and you want to put engines on different machines, you can do that too. The idea is that with multiple engines, you have concurrent capability. So it means that if 3 jobs are submitted to an FME Server environment that has 2 engines, 2 jobs are immediately allocated to the 2 waiting engines, and the 3rd one is placed in a queue. Once one of the engines becomes free, it gets allocated to the free engine, and then it can consume or continue to process that job. You don't have that queuing capability in desktop, so it's something to be aware of. They are very much then a server and client pair. FME Desktop is where you build your process, and FME Server is where you can run it. FME Server's real requirement or capability is that it runs workspaces. There's a couple of times where I've been asked a specific question that says, I'd like to upgrade from FME Desktop to FME Server. Can I do that? Well, effectively the answer is no. That's not traditionally how it works. You need to have at least one FME Desktop license to use with FME Server, because you need to be able to build processes in FME Desktop to be able to use them on FME Server. So you can't have FME Server without FME Desktop, but that's something to be aware of. So within your FME Desktop environment, you would build a process, use the option to publish that up to FME Server, put it onto your FME Server box where it could be run. At any point later on, you could then download it from FME Server from the Workbench interface, download it, edit it, and then republish it and go through that cycle. So you can manage the process and what people can see and access, and make changes as things go along. There is a concept with FME Desktop of additions. An FME Desktop addition means that effectively it determines what you can write largely. So if you buy FME Desktop at the professional edition level, you can read data out of Oracle Spatial, but you can't write it back in. If you want to write into Oracle, you have to buy the database tier a little bit further down here, which costs a little bit more money. And as soon as you've done that, you can write to Oracle or SQL Server or DB2 or Netezza or any of these corporate database environments. The point I'm trying to make here is that FME Server doesn't have additions. What that means is that if you buy FME Desktop at the database level and build a workspace that includes a database writer to Oracle Spatial and publish that to FME Server can write to Oracle Spatial. So whatever you can do with your desktop edition of FME, you can do ultimately on server. So that's a subtle point to make, but an important one that is often a misconception. The same is true of all the formats that FME Desktop supports. FME supports over 325 formats now with the current release of FME 2014. Basically, if the format that you want to work with is supported in desktop, then it'll be supported in server. When it comes to the different roles with FME Server, there's a few to be aware of. You start having to effectively put on different hats as an individual or as different types of user. You can see that from this simple diagram, this is perhaps, if you're just an FME Desktop user at the moment, this is perhaps what you've been used to. You are the FME author, you're the FME expert, you're the person who produces an ETL routine, an FME workbench, to process data from one place to another. Perhaps you're processing Ordnance Survey data every few months. Perhaps you're moving data between your environments. Perhaps you're managing planning applications or street assets. Perhaps you're publishing data to your WebGIS. Any number of tasks that you might be doing with FME Desktop. Perhaps in your organization you have a separate IT environment that's managed by a system administrator. This individual is the person who sets up your access to different network drives and sets up your software and your hardware environments. You probably also have a number of users, one or more users in your organization in different departments using different clients to access different data that perhaps you have created using your FME desktop processes and some of your other applications that you use in your environment. You might also have a web developer or two available to you to do some software development. In reality, the IT administrator, the user, and the author is often a very similar person or the same person in quite a lot of smaller organizations. So it's worth being aware that some of these roles, whilst being quite defined, can be often the same person in some cases. If you've got a web developer or a software developer, they're often somebody a little bit different who sits out in the different part of your organization and is able to offer capabilities to you. And whilst it's handy to have somebody like that, you don't have to do software development with FME Server. There are a lot of capabilities out of the box. I'll show you a couple of examples where it's handy, but you'll see a little bit of that shortly. So just a little bit of an understanding about some of the different roles. Bit of an architecture overview then, just to get a basic feel for the structure of FME Server and how it looks. This is effectively all the things that you get when you buy a copy of FME Server. You get this architectural setup where over at the sort of top left here, this is outside of the FME Server environment. So this is how you would connect to FME Server. So a client of FME Server is FME Workbench. You can upload one of your workspaces to FME Server, and you can subsequently download from Server as well. There is also an FME Server console, which is effectively a command line interface to do the same kind of jobs. These communicate via the API to FME Server. There are web clients as well. So the FME Server web and admin interface allows you to connect to FME Server. But you've also got access via third-party clients as well. So your WebGIS perhaps could connect to FME Server. Your Excel spreadsheets can connect to FME Server, and Google Earth can connect to FME Server, and so can Adobe Acrobat. All sorts of different applications can connect because effectively you're communicating via the construction of a URL, which I'll explain shortly. The web services that you can see here, there's a couple of common ones mentioned there, the data download service and the data streaming service. These are just ways in which you would interact with FME Server. Effectively, a web service determines what FME Server gives the user back. So I'll go into a lot more detail about that shortly, but essentially if you logged into the web interface in FME Server, try to run a process via the data download service, it would pass a request to the transformation manager that says, I want to run a workspace that sits in this repository, for repository read folder. It runs the job that sits in that folder, and it grabs some data, passes that process through to a waiting engine, churns the job, produces a result, and sends that back to the required client, having consumed the data from wherever it was in your networked environment. So, a little bit of an architecture diagram. It's oversimplified, but it gives you a feel for what we're trying to achieve here. I'll get into some demos in a few moments to clarify some of this theory, but just for a few more minutes I want to cover a little bit of detail here around the architecture. The FME engines then, just to focus on those for a moment, these are the things that you're really effectively starting to pay for when it comes to your capabilities. You can have one or more. If you buy FME Server, you get one engine. If you want additional engines, you can have as many as you can run in your environment, or as many as you need. They are, as I mentioned, always running. they will transact one request per engine. So if somebody submits a job, it goes to an engine which will run on one core on your hardware. They offer failover protection, so if something goes wrong, they will try and restart themselves a number of configurable times, and there is the ability to fail over to a separate failover engine on another machine if you need that kind of protection for your 24/7 operation. If you want to scale it, so if your needs change, you can just add more engines. More engines you've got, the more concurrent processes you can run, and the higher the throughput you can have. What I tend to ask customers when they're trying to scope their engine requirements is these two questions here. You can gauge a user's need based on the answers to these questions, really. What's the volume of throughput? So effectively what that means is how many processes are your users going to be wanting to run? So how many times is master map going to need to be processed every year? How many times is a data download going to be requested? People like the the Environment Agency, for example, are looking at around about 8,000 data download requests per year. So have you got that kind of scale, or is it smaller than that? Importantly though, what's the profile of those jobs? How long are they going to take? Because if you buy FME Server with one engine and you want to run national master map process every 6 weeks, and that takes say 5 days to run that process on FME Server, then you've effectively got that engine tied up for 5 days. So you would need to have a second engine to give you the ability to have short run jobs, the likelihood of being processed during that busy time. It's all down to managing your throughput and your requirements. So what I want to do is give you a little bit of a guided tour of the FME Server interface. So let's do that now. Pop up a web browser, takes me to a well-known search engine, and I'm just going to log into my instance of FME Server. So FME Server, this is my own installation locally on my machine, and we can log into that with my username and password. And if we log into that interface, you see the first thing that we do is we get effectively a view of a web page, a number of options down the left hand side over here, and we can also see how many engines we've got available and if they're running. Engines that are listed here are the ones that are available to me, and when you can see them, you know that they're running. So I've got 4 engines sitting here whirring away, waiting to carry out a job. And if I just start my task manager and show you that, show all processes, and we go and have a look at some of the tasks. You can see there's 1, 2, 3, 4 engines sitting waiting, always running, but waiting for a job to arrive. So that's a useful thing to be aware of. We've got access to the admin guide through the help. We can manage whether we're logging in and out and who we're logging in as through the login setup there. And you can see that we've got access to some of the things that are very handy over on FMEpedia, different articles to go and have a look at and different resources that are available. But most importantly, we're going to start navigating our way through some of the setup here. So if we just go top to bottom very quickly through the different capabilities here, we can see repositories. Repositories are effectively a fancy name for folders. So when you install FME Server on a machine, then it gives you the ability to manage the folder structure that is stored beneath FME Server, and this is also managing your database. So you have a database that is automatically installed when you install FME Server. By default you'll get Postgres, that's the out-of-the-box installation, but you could connect it over to SQL Server or Oracle if you wish to do that as well. And effectively inside each of these folders we can see that we have some workspaces, so we'll come back to those in a little while. These are workspaces that are configurable. If I go to this earthquake extrusion process, you can see that it's been registered with some services. More on services in a short while. If I go into the data download service, we can see a bunch of parameters are available for us to start running this job. Whilst we're talking about jobs, if we go over to the Jobs tab, you can see that I can show you all of the completed jobs that we've got. Well, I don't have any because I've flushed them out of my cache, so they've been removed from the database for the time being. The ones that I had done, you'll see some appear shortly. Any that are queued, ready to run, waiting for an engine to be available, will be listed here. Any that are actually running will be defined here. And we can go and see the status and a bit of detail about each of those when they're running. Notifications, not going to go into too much detail about notifications in this session, but suffice to say you can register different types of notification for FME Server to receive or give. For example, a simple subscription notification would be something like if your data download service works okay, then what you might want to do is send a message via email to a recipient that says your FME Server data download worked, put it into a template that you've defined, which you'll see later on, and email the details of that download to that person. So when we work in asynchronous mode, you'll see that shortly. If we go to the scheduling tab, you can see that there's the ability here to define workspaces or processes to run frequently. You might want to back up your FME Server configuration. This is a recurrence task that you can set to run as frequently or infrequently as you wish, and it's supplied out of the box with FME Server. Alternatively, you can run an actual job. So if you had a task that needed to update your web map and you wanted to run that out of hours at 2 in the morning, you could set that up here without having to rely on Windows scheduled services to do that job for you. You've managed it all within this self-contained environment. On the security front, you can manage all your security and access roles to FME Server through this interface. Whether it's users or roles or policies that you want to define, you can set them all up within the application here. If you're more familiar, or your IT administrator would be happier for you to use security through Active Directory, so that users can access FME Server just like they log into their own desktop or laptops in your environment. You can do that too and hook it up to AD with no problem. If I go over to services, this lists a few of the details of the services and how they're configured. More on that shortly. Monitoring is again around different types of topics and notifications, so we're not going to go into that in too much detail for the time being, but more on that in another session. Go over to resources, allows you to manage the access to different data and environments that you've got around your network. Have local data available to FME Server if you want to do that. And if you decide that when the new version of FME Server appears in the future, you want to make life easy for yourself, everything that you've set up, your configuration and your workspaces, anything that's published to your existing instance of FME Server can be backed up, put into a migration file, and then when you uninstall FME Server and reinstall the latest version, if you decide that in January 2015 you want to go to the new version of FME Server, then you can just import your packet of FME Server backup file, and you'll be up and running again very quickly. And then you manage and handle your engine access through the engine tab here to indicate the status, the traffic light system there of whether your FME Server engines are working or licensed, or whether you've managed to stop one of them for a particular reason. So just a very quick whistle-stop tour through the interface there, just to show you a little bit of what it looks like out of the box. I've not made any adaptations to the interface. It's as it is out of the box. The only adaptation I've made is to change the logo in the top corner. So you're seeing what you would see with your evaluation of FME Server, for example. So capabilities then, automation, self-service and real-time, focusing on automation, the ability to put scheduling in place, the ability to access routines from a web interface. So you can open up complicated processes to people who can just access your web page or a web page. It can be a very basic form that you've designed, or it could be a complex one that sits on your web page that perhaps has a web map interface connected to it. And you can use different types of hardware using FME Server, multiple hardware resources to allow you to scale your environment. Self-service capabilities means that you don't have to have any special skills to use FME Server. If you're a user, you access a web page and perhaps carry out a data download. You can upload data to FME via FME Server and carry out validation. So if you want to validate some data and get a report back on whether it's okay, then that's a useful capability. If you'd like to load data into your database and use FME Server to do that for you, perhaps you're a worker in the field and you want to upload some data to your corporate database, which happens to be in SQL Server. You can log on at home, upload the data via the interface that has been designed at the other end. Upload the data, it passes through a validation routine, it checks that it's okay. If it is okay, then it will load it into the corporate database. If it's not okay, then you'll get a message back and perhaps an error report that tells you why it's not okay. So it gives your organization much wider access to ETL routines. And when it comes to real-time capabilities, event-driven notifications, event-driven processes are really handy. For example, you could send an email to FME Server with a photograph attached to it and automatically pin it to a geographic location on a map. There is an FMEpedia example that shows you just that capability. There's all sorts of different options around Twitter and email and SMS with FME Server as well. So if you want to carry out and work with notifications, it's a really handy capability. Focusing then on the different services before I show you some actual demos. These are the standard services that are available to you. You effectively register your FME process with one or more of these services, and what they do is determine the response that FME Server gives to you. So if you have a process that reads data from an AutoCAD file and writes an Esri shapefile, if you publish it to a data download service, a person can log into a web page, click a drop down and say, please can I have the data in this area, click go, and they will get to download a shapefile in their web browser. A streaming service will stream streamable formats. So a streamable format is PDF, for example, which means that you could stream a PDF into a web browser. So somebody clicks a button on the web page and it generates a PDF on the fly and shows you the results with the existing and real-time data included in that PDF at the time that the person called on the PDF generation. There's also a KML network link that connects very tightly with Google Earth and Google, and the job submitter service is a capability that it really just runs jobs on FME Server, does exactly what it says. All of those four services have the ability to allow you to upload data to them through the web browser. There's also OGC services, so FME Server allows you to generate web map and web feature services. There's a notification service, and then if you want to create an interaction programmatically with FME Server, then REST is the way to go. And there's also a catalog service. The two at the bottom there are slightly different to the others. The catalog service allows you to effectively make FME resources available across the different your organisation, essentially. So we've got some questions coming in at the moment on the chat window. I'll address those towards the end of the session, if that's okay. So hang on till the end, and I'll cover those answers towards the end. So if I focus on what a service actually is, then as I mentioned, it determines the response that FME Server gives to you as a user. So you have whatever client you're using, the service itself, and the server. Effectively, that could be a web browser, the FME data download service, and FME Server therefore provides effectively a zip file. So that's what happens. The workspace that's registered with FME Server ignores the output that's hard coded in the workspace, and what it does is when it comes to write the output, it compresses it into a zip file and issues it as a download in the web browser. So on to some demos then. Let's have a look at some of these. So I've come up with some of my own acronyms here, and I've used some common ones as well. DAS is a well-known acronym that's used in our discipline at the moment, Data as a Service. TAS, maybe not, but you'll see that I've made a few more up as we've gone along here. Looking at data as a service, then the ability to download a selection of data or clip out a little bit of data as a self-service task is pretty handy. If I go and drag my FME Server interface into view again, go into repositories, go to samples, and we can see that I've got a workspace here called Austin Download. This is the standard one that you'll get to see when you have a look at the evaluation of FME Server. You can see here that the Austin download process has been registered with a catalog service, a data download service, and a job submitter service. If I go and have a look at the data download service, I can configure it. And then I've got a few options. So first of all, we could have a look at, and I'm just going to open my email client just briefly and tuck that out of the way, because I will send myself an email in a moment. So we'll see that we've got the option to email results here. So I'm going to work with this synchronously at the moment. So I've got the ability to select all the layers, or deselect all, or have access to any one of these. So if I go for airports, so this is an input data set is available to me. The workspace that's been published can access this information, and we can see we've got our airports layer. And what we can do here is check that we're going to get some data in an output coordinate system. So we'll go for a world coordinate system. We want the data in shape. We can define a clip region if we want to by specifying some min and max coordinates, and then specify the search envelope. And if I just run this process, because this is registered with the data download service, it submits a job to FME Server, and it gives the user back a successful job, which includes a URL to a zip file, which I can then download, show that in a folder, which is just over here. And then if I just go, and rather than extracting it, I'll just go and open up the Universal Viewer and put that in view here. And those of you been using FME for a little while know that FME can read zip files. If I tell it that it's got a shapefile inside the zip file, I can drag it and drop it into the inspector, and you can see here that we've got our airport data. If I turn my background map off, I've just got a little Stamen web service there. There's my airport data that I've just brought in, and that's in a shape format. If you want to prove that it's actually in shape, I will extract it. Go to 7-zip and extract it here. Have a look in there, and there's my shapefile that we just processed. So took that out of the way. So that's the process carried out in the interface. If I go back to my repositories, go back to my samples, Austin download and configure here, and this time I'll go and email myself. So this is an asynchronous response. So okay, and this time we'll send the data to a different format. So like that data in Google Earth, run the process, and because I put my email address in here, the interface just tells me, and you can define this as a template that gives the user some expectations of when they're going to get their results, but this tells them that they're going to get an email sent to them that contains the link to the data. And that ping was that email arriving. And here, because I've set a template up in FME Server, I've now got that same URL available to me in an email as and when the job finishes. So if you want to manage a user's expectations because you've got only a couple of engines and a lot of data being supplied, you can use that email submission. And now we can go and extract that. And there's my KML file. And if I go to Google Earth, we can see we're heading to Austin, Texas. And there's the same airport data available to me. So, just a little overview there. Close a few things, close my email so we don't get interrupted from that again. If we go and have a look at FMEpedia to have a look at a very similar example to that, we can see a prettier version. And this is, if you go and have a look on FMEpedia, you can look at data distribution with web maps as an article, and here you can see that there is a couple of integrations, either using a Google Map background or an ArcGIS Server background. I'll go to the ArcGIS Server one. This is a live demo that you can go and access. We can go and draw a polygon around the area of interest that we want to get some data for. And you can see that effectively down here you're building a URL. So this is the URL, and there's the important part, it's running a workspace on the data download service. I want to have bus routes and bus stops supplied to me in the area that I've just defined, and that's added those into the URL. You saw the URL extend there. I'd like the data in a lat-long coordinate system, and I'd like it supplied to me in GML, please. If I request that data, the results are returned within the browser, and now I can go and download it. Show that in a folder. Just get rid of some of the data that I downloaded previously. Extract that here. And now you can see I've got a GML file that contains the output that we're interested in. Pop that across. And now we've downloaded our bus stops and bus routes for this particular area of Austin, Texas. So, just a quick example of how you can integrate a web map with this kind of process. Very similar, all of the parameters that we looked at are available here. It's just that you have that web map included. So translation as service, my made-up TAS acronym there, upload a file and get something back. Well, with FME Server, out of the box, you get a nice little service available to you. So if we go to our repositories, go and have a look at samples, you can see there's an easy translator here. And if we go and register this, have a look at this with the data download service, we can see that we've got the ability to add a file. So in a web interface we can upload there we go, we can upload a DGN file, upload it to the interface. It's made it available, and you can see that it tells me I've got to go and have a look and associate that with the process in the upload tab. So we'll tell it that we want that DGN file to be used in the process. So effectively I'm a user remote to my organization, logging into this web page, uploading that DGN file. I'd like FME Server to guess what the format is from the file extension, define the input coordinate system. Well, I know it's in a Texas coordinate system. What my output file is going to be, it's going to be called translated data. It's guessing the file extension, it's specifying the coordinate system, and we're going to upload it in MicroStation format, and what we'd like to get back is an AutoCAD format. So we'll go and get back an AutoCAD file format in a different coordinate system. So we'll go and get that in a lat-long coordinate system there. Now if I run that process, we're effectively uploading a DGN file, and as a user we're getting a translation here as a service. We're just getting back an equivalent file, and that will come back as an AutoCAD file instead. And there we go. So I could download that and have a look at the DWG file that's inside. The same is true on FMEpedia. We do also have the ability to go to a slightly prettier version of the same process. Anybody who's on the webinar can access this. Easy translator using FME Server, run it live, and here you go. You too can go and add up some files, add my DGN. We get a prettier interface that's been designed here. Select that file, guess the file extension, get a DWG back, get it back in the same source. There we go. So now I'm uploading a DGN and getting back an AutoCAD file, and then I'm available to download that. If I want to go and do another one, I can just go back and I can start again by refreshing this process. So just refresh the page and start again, upload another file and translate some content. So useful little examples, hopefully, to give you an indication of that. Focus then on data services. So again, more acronyms that I've made up, but validation as a service. Look at a quick example here. So to do this, we'll pop up FME Workbench. Bring in a little workspace, and here you can see a process that has a publish parameter. This is a publish parameter, allows me to put in here a postcode, and the creator creates a single feature, fetches that postcode, passes it through our UK postcode validator to check whether it's valid or not, and then effectively inserts some information into a little HTML template. So this attribute creator, inside it, has got a little HTML template. So all I'm doing is populating a little template and replacing these values here where I've got the insert values. So if we just run this as is, send that postcode through to a text writer. The text writer is actually writing out not a TXT file but an HTML file. So if I open the containing folder, there's our result, and you can see that that postcode I passed in is valid, and it even reformats it for me. Okay, but that's not much use as just an FME desktop workbench. What we'd want to do is go and publish this up to FME Server. Publish it to FME Server, we can log in, push our validate postcode process up to my demo location, and I'm going to specify that process with the data streaming service and publish that up. Now if I go over to FME Server, dive into the repositories, have a look at my demos, I now have validate postcode available to me. It's registered with data streaming. I can configure it, and the same parameter that I had available in desktop is now available for me here. So if I type a word, not a postcode, run it, the process is run, it writes it out to HTML, which is streamed back into the browser, and it tells me that the word help is invalid. It's got alphabetic values, therefore it's not a postcode. If I put a postcode in the wrong case and run that process, it is valid, it's in the wrong case, and it's not got a space in it, so we can get that to reprocess that. So it's an example of how you can do a simple validation routine. This is a very simple validation routine, but one all the same. The important thing though is that we can show the developer information and see how we can run this process, because here you can see that it is, after all, just a URL. If I change this and refresh it, you can see that the URL changes. If I copy that URL, go up to my browser, paste it in here, and change that to 1234 and run the job, I have to authenticate against my FME Server interface, but now I get the result, but that's only a numeric value. So the other thing that we can do is very quickly build a web page. Copy the URL, create a new text file called test.html, and copy that post information into a notepad window, save it, close it, double click it, and now we've got a web page. Run the process and we get the same response back. So you can very quickly, with very basic HTML skills, design a web page to report the results of your process using the form example. So everything's in here for you to have access to. So a little bit of validation there. Have a look at a map as a service. So if we go and have a quick look at the slides again, here you can see that there's a data streaming example that sits over on FME Server, and we're going to open up a web browser here, and what you can see is that this is actually a URL to a hosted instance of an FME workspace that produces a dynamic PDF. Here's your PDF. It's a very simple PDF, contains a map within it, and there's a little view at the bottom that gives me a grid. So if I want to go to L27, if I click it, the URL changes and says go and create the PDF for tile name L27. Now this could be extracting data live from an Oracle database, but it's pulling it straight from that database and putting it straight into a dynamic PDF at runtime. Go to a different tile, go to N27, double click it, and now we get to see the data that's inside N27. If I just go and change the URL up here and change that to N25 and press return, it runs another FME Server job and gives us a different map each time. So imagine having a little hyperlink on one of your web pages where people go to download a PDF, and when they download the PDF, every time they run it, they always get a different map or the latest version of that map each time they download it. So a very handy capability there. So let's focus on a little bit of business intelligence. We want to carry out a query as a service to find out, in this case, a little bit of information about what region a particular feature is in. So to do this, I'll show you another process. So here's a process. It's got more transformers in it than you need. It's just I wanted to break them down and show you exactly what's going on here. We have a creator that effectively is going to go and grab and create these X and Y coordinates using the vertex creator, create a location, a pin on the map basically. I'm then going to check if that pin falls within a postcode boundary, a district boundary, a Scottish and Welsh government region, and ultimately find out which settlement it's nearest to using the neighbour finder. So this is effectively a process of pointing polygon to find out where am I. I'm going to write the data out, in this case to KML, and if I prompt and run, just put in a couple of values here, so a couple of X and Y values, run that, right click, and when it's finished, I'll open the containing folder. I get to see a KML file, and it puts a pin on the map. And we can see that we're somewhere in Scotland, and this pin tells us that we're actually in the city of Edinburgh. We're within that postcode sector, that Parliament region, and the nearest settlement is Morningside, and it's just over 1 kilometre away. And there's Morningside over in the distance. So let's just tuck that away for a moment. So that's our little process. Now if we publish this process to FME Server, what we've got is the ability here to carry out some really neat little queries on our data. So I'll go to the where am I process here. I'm going to register it. It's already registered with the data streaming process. Now I can plug in any value I want into here. Run that process. And it streams the results directly back into Google Earth. And here we go. So now we're off in a different place, and we're now in West Lothian this time, and the nearest location, nearest settlement is Tarbrax, and it's just under 5 kilometres away. So because all the time all we're doing is building a URL, we can then take that one step further and start to use this for people who don't want to use the FME Server interface or a map interface. Perhaps they're more of an Excel person. So you can create or define, allow them to understand what the URL is that they need In this case, it's a URL to FME Server, runs a workspace, got a different set of coordinates in it each time. So you can obviously hide the URL if you don't want the user to know how it's happening, highlight a hyperlink. But if I click on this URL, it runs an FME Server job, and now they get a little bit of KML automatically, and they can go and see a different location. So each time they can go to a different place and find out more about that site using Excel as the client instead. High volume data crunching is where I want to finish up. Just to look at the job submission service. Job submission is really, this service is probably the GIS manager's key tool. The capability that is most like running a job on FME Desktop, but instead you're using it in this enterprise environment of FME Server, perhaps with much more heavy-duty hardware available to you to use. I'm going to show you a way of carrying out a batch run using FME Server. But first of all, I'm going to show you the equivalent capabilities using FME Desktop. So let's close the process that we had open a moment ago, and I'll go and find the process I want to highlight to you. So I'll just go over to data crunching. It's a rasterization process. If I just dive into here, you'll see that I've got some DWGs. So a whole bunch of DWGs. This is master map data stored by tile. I've got an output directory that contains nothing at the moment, and I've got a rasterization process. So I'm going to rasterize master map effectively. So a very simple workspace to do the job. Read my AutoCAD data, set the coordinate system to, in this case, British National Grid, because the CAD files don't know where they are, and then carry out a rasterization to create an image with a white background and a cell size of, in this case, defining a square bit of raster data. And if I prompt and run, I can define it to run using one of the DWGs, and it's going to go to my output directory. And if I drag the output directory just into view, run this, and you'll see that in a second a TIFF file appears with a tab file georeferencing file. So this process is defined to run. I'll just zoom in a little bit here. You can see that we've got a settlement somewhere in there. It's not a very detailed bit of raster, so we'll run that process on another file in a moment, effectively rasterizing that image. So we can run this with a different one and let that go. But if we decided to run this process, because it's designed to work with one file, if we run it with more than one, the downside is that we end up stringing all those DWGs together into one image. So we'll find that when it creates our TIFF file over here, it's a long TIFF file, and the naming convention then is incorrect. We built this process to do work on one file at a time. So here now is our raster, and you can see that if I zoom in, we've got very long raster image. I can pan around here. So it's not ideal at the moment. So what we would do is get this process to be called by another process. So if I close this down and go and open up another workbench, and this time we're going to run our open up our runner. So bring the runner process across, and here, if you're an FME Desktop user, you might have discovered the workspace runner. The workspace runner, I need to throttle it and allow it only to run 2 jobs at a time, because you might have a machine that only has 2 cores. Here I'm going to get it to read in the DWGs that I have in that folder and send them to that other workspace. So if I run this now, go and open my output directory, you'll see that effectively I will start to create 2 TIFFs at a time. So slowly that folder is going to build up, and all those 50 DWGs are going to make their way through this process and be built into individual TIFF files as we go along there. So I'm just going to stop this process because we don't need to let that complete, and the last couple we'll just finish off here. So now if I can click through these TIFF files, we can step through the different TIFFs that we've got stored in here. So let's delete that little lot here. So now if we want to go one step further with our FME server, we would use the FME server job submitter instead, and we're using Workbench as a client of FME server here. If I go and dive over to FME server and go to my job page, you can see here the jobs that I've been running so far this morning, any that are queued and any that are running. So if I just took that out of the way for a moment, go into my FME server job submitter, you can see that I can go across, register this process with the master map rasterizer that I've got set up, and specify the priority of the job. These jobs are all the highest priority, and effectively however many engines you've got now can run at a time. So I've got 4 engines, so I can run 4 jobs at a time, double the amount that I could do with the workspace runner. If I run this process, it'll submit all the jobs directly to FME server, go to the queue, and you can see that all my jobs are now queued here. My machine slows down a little bit because I'm thrashing all of my cores. All of these 4 are running, and if we go to the completed, we can see that they're starting to rattle through here and finish. And if I go to my output directory, you can see that I've very nearly finished all of the TIFF creation already. So we've got 25 items created there, halfway through the job run straight away. So the job submission service is extremely powerful for batch running jobs and carrying out heavy duty data crunching. So just to complete the session then, really just want to summarize a handful of things. Top 3 reasons why people buy FME server. One of them, the main one really, is the ability to have a data download service, to be able to offer data to your colleagues, to third-party contractors, to individuals outside your organization via a web map interface. Allow them to pick some drop-downs, choose what they want, and download data. The second reason is where FME is used as a data sentry. A user has the ability to upload data to a service, to a process that sits effectively in their cloud and allows them to carry out validation on that data. And then the third one there is for heavy duty data crunching. People buy FME server for a GIS team to carry out very robust data crunching, heavy duty data crunching, in a more enterprise environment that has the capability to use heavy-duty hardware availability. So these are just some of the reasons why people are using server to do large transformations, to extract data from the definitive single source of truth, offer download services, and to do that kind of crowdsourced validation. So we're at the end of the session. I'd like to thank you all for joining in today's webinar. I want to let you leave with a handful of resources to take a look at. So here you can see that if you go to safe.com, you'll see SAFE's website. Lots of information on there around about the FME products. They have a specific FMEpedia page, FME-server on FMEpedia. Very, very useful site. Gives you access to all of those live demonstrations that I've shown today. You can come and see us at onespatial.com/FME, or go and look at some of our other webinars on our YouTube channel, One Spatial Group. This one will appear there at some point fairly soon. And then, of course, that FMEpedia site is extremely useful. I highly recommend you going to take a look at FMEpedia. It's extremely powerful. The knowledge base alone has over 1,000 articles sitting in there of how to do certain things. So I'd like to thank you very much for attending today's session, and now I will just drop over to have a look at some of the questions that have been drip feeding their way through to us. So for now, thank you very much. If you asked a question, then hang on, and I'll respond to a few of those right now. Okay, so a couple of questions then. How many engines does FME Server come with? Okay, so if you buy FME Server just alone, just buy the FME Server product, you get an engine with it, a single engine. You can scale it by buying additional engines. So you pay one price for FME Server inclusive of an engine, and then additional engines are a smaller price, and each one of those is the same cost. So that's the way. So effectively, if you want 5 engines, you buy FME Server. It comes with one engine. You then buy 4 additional engines. If you want information on pricing, then feel free to drop me a note direct or email us at fme@onespatial.com. How does FME Server write to an Esri geodatabase? Okay, so the person who's asking that question must be aware that there are challenges with some of the Esri formats. The challenge is such that you have to have Esri technology installed on the machine that needs to do the writing, because using the ArcObjects writer to write to Esri geodatabase requires some of Esri's libraries. So effectively you need to have some Esri technology on the same machine that FME Server is installed on if you're doing that kind of thing. There is one addition or one benefit, and that's that there is a free API to write geodatabases as well, so that answer is a little bit muddied by the fact that you can write geodatabases without Esri technology, but I would highly recommend you go to FMEpedia and type in there Esri compatibility on that page. That will take you to the Esri compatibility page that gives you a lot of detail about that type of question, and that one in particular. And then we've got another question in here. Can engines be allocated to a service or a group of services in order to manually load balance or allocate engines for particular types of tasks and requests? And the answer is yes. Each engine or each task can be assigned to a particular engine by giving it an engine ID in the URL that you're passing across. You can also reserve certain engines for certain types of jobs using a configuration setting in the product. So you can manage your engine allocation. One scenario we had a little while ago was where a customer needed to actually install an engine on a different operating system. To be able to, they had a FME Server installed on a Linux environment, and they needed to write some Windows-based formats, so they put an engine on a Windows box. That was a scenario. They used certain jobs, then got sent to that Windows environment. Anyway, hopefully that's answered all of your questions. For now, I'm going to sign off, and thank you all very much for attending. If you want to get in touch with us, there's my contact details, and you can go and have a look at our website. But for now, thank you very much indeed, and goodbye.